When we are graphing rational functions, it's important to know that there are many details that we're not going to be able to show. So we're just going to focus on a few of the following details. So we're going to show holes and vertical asymptotes, horizontal and slant asymptotes, zeros and y-intercepts, and the basic shape of the function. So for the holes and vertical asymptotes, we need to know where they come from. The holes and vertical asymptotes come from the denominator. The slant asymptotes and horizontal asymptotes are related to each other, and they're really what we would consider endpoint behavior. So what's happening at large values of x. And the zeros are going to come from the numerator, and the y-intercept is when we plug in y equals 0. Okay, so this is, when x equals 0. So we substitute x equals 0 into the expression. Okay, so let's take a look at what we have here. In the denominator, we have a restriction of x equals 1, or x cannot equal to 1. And it's either going to be a whole or vertical asymptote. Since it doesn't cancel, it is a vertical asymptote. So I'm just going to draw this here. At x equals positive 1, we're going to end up with a 0 in the denominator, so we're going to draw a vertical asymptote at x equals 1. The 0 is going to come from, so I'm going to do the 0 in green, it's going to come from the numerator. We make the numerator equal to 0, and we solve this equation equal to 0, and we get x is equal to 2.5. Okay, so it's going to cross the x-axis here. When we talk about the slant asymptote or the horizontal asymptote, when we have the degree in the numerator that is the same as the denominator, what we do is we take a limit. We just say what will happen as x gets really large, of 2x minus 5 over x minus 1. Well, these terms become insignificant, so we end up with 2x over x, so we have a horizontal asymptote at 1. So at large values of x, the graph is going to tend towards this value of y equals 2. The last part here is our y-intercept. So if I plug in x is 0, my y value is going to be y is equal to negative 5 over negative 1, which is 5. So we get a y-intercept at 5. Now, if we want to know some more details of this, we can plug in some more points into this expression. But generally now, we should be able to draw the graph, because the graph is going to follow the asymptotes, go through the coordinates. So we're going to have this general shape. It's going to be this rational function going this way, and it's going to, if it's pointing up on one side of the vertical asymptote, it tends to point down on the other side, and we get this graph that looks kind of like that.